Today we're here to talk about thermochemistry and stoichiometry. Okay, there's a direct relationship between the chemical reaction and the delta H that is produced. And we can relate the grams. We can convert from grams of any substance in the chemical equation to heat, just like we did in stoichiometry when we went from grams to moles of another substance. So in my problem, my given is 15 grams of CO2. So I'm going to write my given down first. And the relationship, remember, in an equation is always in moles. So the first thing I want to do is convert those 15 grams to moles. So I used the periodic table and looked up the mass of CO2, 44.1 grams in 1 mole of CO2. And then there's a direct relationship between the 3 moles of CO2 and the negative 2,201 kilojoules. So to cancel out the moles of CO2, I'm going to use the equation and see the 3 moles of CO2. And then I'm going to put the amount of heat on top, 2,221 kilojoules. Okay, now my answer will give me kilojoules of heat, so that's all I need to do. So now I need to take 15, divide it by the 44.01, multiply it by 2,221, and divide it by 3. That gives me 252 kilojoules of heat evolved. Now, why not make it negative? Since it asks for the heat evolved, it's saying that it will already be negative, so there's no need to put a negative sign onto the number because there's 252 kilojoules evolved. If it just says how much heat how much heat would be in the relationship with 15 grams of CO2, then I might want to put a negative 252 kilojoules. If it just says how much, if I have 15 grams, how much heat what is the heat change? Then, if it's talking about the heat change, I'm going to put negative 252 kilojoules. It just says how much heat is evolved. 252 kilojoules of heat is evolved. So that is my final answer. And that's all there is to stoichiometry and thermochemistry together. Simply convert your grams to moles, convert your moles to the heat using a direct relationship between your equation of what you got to the amount of heat produced.